Please welcome to the stage, James Bach.
Thank you. Thanks. My voice is booming. Good, good. So shortly before the talk today, I was informed that my 60-minute talk would be a 52-minute talk. But it's okay. It's getting better, iterating here. Testing. I guess I'm first because it's test first, right? Which is ironic because I'm actually don't like the whole test first idea. I'm kind of a speak out against it. But here I am, emblematic of that here. The tester goes first. Okay, well let me open with these words. A test is not a thing, a physical thing. It's not an artifact, it's not a pattern of bits. A test is not code. No one here has ever written a test. When you say I wrote a test, you're speaking in the way that a playwright might speak when a playwright says, I wrote a play. No, you wrote a script for a play. The play is when the actors are on the stage performing. And that's not a trivial thing. You don't just say, well, I wrote the script, that's it. I have now completely specified this movie or this play. So when you write a test, it's very common in the industry to point at it and say, that's a test. I say, and I'm only speaking as someone who's been a passionate tester and testing thinker for more than 30 years at this point, 31 years since I started at Apple Computer. I think Kent Beck was working at Apple at the same time I was. I never knew that for sure. But I'm passionate about testing. I say that testing is a human experience. It's a human event. When I say I have created a test, I mean I've created an experience. I've created an event. Of course, it's supported by code. It's supported by patterns and metaphors and concepts that we share in common and things that are static and other things that are dynamic. But I'm always talking about a human experience. And that's what makes testing worth studying. So Kent Beck, years ago, wrote a book, his white book, where he said in the book something that absolutely infuriated me. Oh, I was so angry with him. And the anger lasted about 20 years. Which is, he said, no one likes to test. No one really likes to test. To me, I felt like I'm a person who loves reading mystery stories and solving the puzzle. And then someone says, well, no one really likes reading mystery novels. Can we be honest? Like, no one really enjoys that. Wouldn't you rather have a book that just tells you who the killer is right at the start and then just goes backwards from there? Wouldn't you just rather have that? Like, no! I love the experience of sleuthing. That's to me what testing is it's exploring mysteries. It's exploring what we believe is true and finding out what part of that is wrong. That to me is the essence of testing. It's a very human social experience because at the same time that you're trying to work through the logic of things, you're working through the significance of things. You have to know socially, am I pursuing a bug that even matters? Because if it doesn't matter, I shouldn't be pursuing it. So now that's a social judgment. So we have intellectual stuff, analytical modeling, automation. My son is updating his novel. I'm sorry, I didn't realize that I was online here. Let me just, before I get a Skype message from a 14-year-old doll expert who calls herself Super Fun Girl, I would like to go into airplane mode here. That actually happened with a bunch of lawyers when I was sharing my screen the other day. Super Fun Girl says, you're coming to Stockholm. Like, okay, let me explain who Super Fun Girl is. She's a homeschooled girl, the daughter of a colleague of mine. I promise that's what's going on here. Okay. I was trying to explain, but I was laughing at the same time. It was so tough. So, what I want to talk about is beauty is a human thing. If you write a simulation of a universe with particles bouncing off each other, you can look at it and say, that's beautiful, but it won't say it's beautiful about itself. You won't invent beauty in your simulation, or you won't be able to convince any other human that you've actually done that, any more than you can program a computer, an ATM machine to say thank you and have someone go like, that's amazing. You've taught the ATM machine to feel gratitude. That's amazing. What kind of machine learning was that? It's a print statement. So I'm not saying that pass and fail is wrong. I'm saying it's uninteresting to me compared to so much more we could do in testing. So I'm not saying stop talking about pass and fail, even though in my testing I rarely speak in terms of pass and fail. I don't think it's interesting. Any more than if you have a spouse and you have something you want to talk about with her because it's something that's important. You don't just point at her and go, fail! Like, hold up a red card and point. You don't, and then green when it stops. You have a conversation. So I suggest detach from pass and fail. Instead, ask, what problems can I see? That's my attitude when I go in as a tester. Even if I'm using lots of automation, and I am very in favor of automation. I use automation like crazy. I'm like a carpenter who uses power tools. Nobody says to a carpenter, are you one of those automated carpenters, or do you use your fingernails like those purists, just chipping away at the wood with your fingernails, gnawing at it like a beaver? Like, no, I use tools, but that doesn't mean I'm an automated carpenter. And nobody asks you coders, are you an automated coder or a manual coder? Because everybody knows who codes that the typing part of coding is not important. It's not important to talk about that. That's not the essence of it. It's the thinking part. It's only because people misunderstand testing as something involving typing on a keyboard that they even say, oh, you must be an automated tester because you don't type on the keyboard. But when you refocus to a human-centered idea of testing, then this becomes a more interesting question. What problems can I see? So I want to maximize the chance that I will see problems even if I did not conceive of the problem before it occurred. And that's a fundamental issue I have with the whole test first concept. Is you can't test first because testing is an encounter with something, making sense of it and evaluating it. What you can do first is you certainly can imagine 6 or 60 things that could go wrong, and then you can say, I want to look for those things. And yes, that's helpful. And can we automate some of that? Oh, yes, we can. And let's do it. But that's not all of testing. That's part of testing. That's a technique that supports testing. Absolutely. Let me get some oracles in your heads. Some heuristics in your heads that you might not have thought of before. I am going to refer to these concepts. A trigger heuristic. A trigger heuristic is some method of becoming aware of something that needs your attention. Obviously, an alarm clock is a trigger heuristic. A radiator heuristic. I pulled that right from information radiator out of the Agilist idea set. Is a heuristic that is beaming information at you to help you solve a problem, but does not tell you what the solution is. It's just giving you information that you need to solve the problem. And then a decider heuristic is some way of saying, we're going to do this, or that is a problem, or that isn't a problem. These three things are part of every tester's work, whether that tester has ever thought of what the word heuristic means, whether that tester has ever thought of the words trigger, radiator, decider, whether they've ever put anything in the words. If you just watch any tester working, you can say, oh, there's a source of information, there's a tester interacting with it, and then, oh, the tester just noticed something because that blinked, and that was the trigger. He was looking for a blinking object. And now the tester's made a decision based on something that somebody said or something that was in the spec. So you see, they are using these different ideas. An oracle, meanwhile, is any heuristic for recognizing a bug when you encounter it. That's important because you can experience a bug and have no idea that it's a bug. You just look at it and it just seems like behavior. It's just more behavior. So an oracle is whatever means you were using to say, ah, that's wrong. Of course, an actual assert statement is a kind of oracle, because that's the part of code where you have said, if you see this, then alert me. So that's a trigger oracle. Any assert in code is a trigger oracle, I would say. All right, now, with laying that out, let me talk about some real life stuff. So a few years ago, I'm testing a medical device. The medical device sends, let's call it, healing energy into the human heart. And we don't want it to be killing energy, we want it to be healing energy. So my job is to test this thing for safety, and among other things, I need to test its power output. The requirements say that you turn on the power, and you have it for a certain number of seconds that you designate, and that's the length of the therapy at whatever level that you set. And then the spec said that it can be up to 10% off, plus or minus 10%. So I conceived of a way to test this. I thought, I'm going to use a two-tailed confidence interval, which is great because I'm a high school dropout and I have only studied statistics because I think it's fun, and I've never actually had to use statistics in a professional setting, so I'm excited to finally use all these textbooks that I bought over the years. I piled up my textbooks and boned up on all this stuff and figured out what the formula was that I had to use. But they said, well, write the test case. And I said, no. Well, you have to. It's medical device testing. You must formalize your testing. I said, no. Until I see the product, I will not formalize my testing. Here's a nice heuristic for you. Never formalize your testing before you have informalized it. Because, guaranteed, as soon as you actually see reality, you will realize that your initial idea about the test was wrong. Now, I know this flies in the face of test first, but again, test first isn't about test first. Test first is about output first. Actually, it should have been called output-driven development, or ODD, not TDD. And it's great, output-driven, it's fine, output-driven, but my testing process involves making sense of things. And that requires me to encounter data first. So I said, I'm not going to formalize this because I'm just going to have to rip it up. I'm wasting your money, dear client. And I refuse to waste your money. You pay me too much to have me just waste your money like that. So they said, oh, okay, whatever. So I go into the lab, and this is what I see the first time I hook up the power meter and actually see what this thing does. This is wrong. But the first thing I notice is, oh, I can't use my two-tailed confidence interval because that mathematics is based on random variations from the mean. And those are not random variations. That is a damped oscillation. So I can't use the method that I thought I would use. Good thing I didn't declare that I was going to do that and write it down in stone before, and then present it to the FDA before I had ever seen the product for the first time. Of course, I told them, like, this is a bug, right? And they go, oh, no, that's just how it's designed. No, it wasn't in the requirements. Redesign it. No, that would be really, really expensive. We can't do that. Okay, so now we got to change the requirements. And they said, yeah, let's change the requirements. That's what we'll do. So after working in the lab in an exploratory way, experiencing what this thing was, I came up with a more nuanced idea of how to test this, that we would use statistical analysis after a settling period, and then whenever we change the power, we would use a different standard. We would say, if the power doesn't go above this line for a rolling average of 1 second, then we're going to say that is okay, et cetera, et cetera. Now I want to focus in on one aspect of that, power down testing. Does the thing turn off when it's told to turn off? And there's the data I have. Now, in blink testing, which I will define in a moment, in blink testing, literacy matters. You need to understand what the data means to some degree. You don't need to know necessarily very much about the data, but the more you are literate, the more you understand what the data means, the more powerful your blinking ability will be. So here's something you need to know. This data you're seeing before you represents 131 therapy sessions for this cardiac ablation machine trying to turn off. They were all performed in a single day in sequential order chronologically. Each line of data starts when the software says, I turned it off. And then I arrange the data so that it goes 10 measurements after it meets the standard of being turned off. And then I cut it off after that. Measurements are in watts. Low power is being off is considered 10 milliwatts. So I zoom this data out, and I can't see the numbers, but I can already see every single one of these is a fail. So if fails matter to me, then it's all failing right there, because that is more than 12 columns in each case, and so that therefore it couldn't have turned off in a fifth of a second if I'm looking at this data. But I'm not going to get a lot of meaning from this with this method, so I start coloring it. So now we see that red means it's above the standard for being turned off, and otherwise it is considered turned off. And just look at this and notice patterns. That's a blink test. Look at it and wonder about it. Run your eye over it. You may need to give yourself a few seconds. So if you look at it too quickly, you might not get nothing out of it. You might not get anything out of it, but you don't need very long to say, there's something long on the bottom, and there's this long one at the top. That one really stuck out for me. A second and a half, more than a second and a half. Now these are therapies, mind you, that last about 30 seconds. So you're getting a second and a half of extra full power of the therapy. That is potentially dangerous, I would imagine. The doctor wants 30 seconds of therapy. The doctor gets 31 and a half seconds of therapy. Probably not good for the heart, potentially. So I question that. When I did, I found out that the people who collected this data, which were not me, they were following my test procedure I defined, and they collected the data and sent it to me in America. They were in Israel. I found out that they didn't follow my procedure. They were using a logging system that was in a different computer, and the clocks were not synchronized. And they realized it after the first test, and they synchronized the clocks. But my procedure said you're supposed to run the logging software on the same device that you are testing so that the clocks are absolutely synchronized. They just ignored that. What else are they ignoring? This is another reason why I just think it's so silly that employers, especially in the regulated world, they keep being so focused on like formalize your tests, write down your test cases, as if people just follow things that are written down, but we don't. People don't follow things that are written down. You can tell people to do this all you want, give them checklists. They don't follow the checklists. Sometimes they do, but usually they don't, or you can't count on them doing that. And yet there's this persistent myth that if you don't write down a test, who knows what's going to happen? How about if someone's not motivated, skilled, supported, then you don't know what's happening? I think that is probably a better way to do it. But down here, this is interesting too. I had no idea this was even possible. It turns off, turns on again for a few seconds, and then turns off. Electricity is scary to me. That's why I like the world of software, but this is what the log file is telling me. So I decided to get some more nuance here, so I created a more graduated coloring scale. And then I adopted something called the low bridge heuristic. The low bridge heuristic says I'm not just interested in fails, I'm interested in almost fail. Almost dead is interesting. So when I said like, let's make the light gray represent turned off, but almost not turned off. So 10 milliwatts to 8 milliwatts, right near the edge. Now I notice something, and you notice something too. The afternoon seemed to have a harder time shutting down than the morning did. Why? What's that about? Is there electromagnetic interference? Is it heat? Did they change something? Raises interesting issues immediately. And then in the middle of that, there's this one weirdo, which when you look close at the data, it's not as alarming. Yes, it turned on again, but it only got up to about 12 milliwatts, which is pretty small. Therapeutic power level, just so you know, is 2 watts. That's the lowest therapeutic power level. And it's not actually putting electricity into the heart, it's turning electricity into heat. So as you might imagine, 2 watts produces a certain amount of heat, but a tenth of a watt, not much heat. So the safety level is maybe not too bad. Then I went through a defocusing process where I said, maybe I'm focusing on the wrong thing. Maybe I'm fooling myself. So I decided to use Excel's default coloring. And as soon as I did, I realized, oh, this is a mix of high power shutdowns and low power shutdowns. I honestly didn't notice that before this moment because I had not looked closely at the data in each individual data in each individual line, which goes to show that when you're blink testing, yeah, you're going to miss things. You'll see interesting patterns and you'll miss interesting patterns. What does that mean? It means that blink testing is a heuristic. It's one technique that we use, but we don't rely on it to do all the work that we need to do. I also noticed that, and you can barely see it here, that the higher power it starts from, the longer it takes to shut down, which I guess makes intuitive sense. But before that moment, I didn't realize that I need to systematically test high power shutdowns versus low power shutdowns. Now I want to maximize that. So I became aware of that variable through looking at this. And then I thought, my client is going to come to me and say, yeah, they're all fails, but maybe they're all really minor fails, and we can convince the FDA that it's just fine. It's not dangerous. So how bad is this really? So then I thought about it, and I thought, why don't we color it so that we're seeing how fast it takes to get down to nothing once it starts getting down to nothing. And so this is from the 90% of start level to a tenth of a watt coloration. And as soon as I saw that, I said, well, now I want to justify the data. So I wrote a little code to justify the data, and boom. Now we're looking at this, and this actually is pretty close to a fifth of a second to shut down if you loosen the standards a little bit. It still all fails according to the requirement, but I am preparing to answer my clients' questions that they are inevitably going to ask, and they're probably going to just change the requirement anyway to fit whatever this data is. That's what they often do. And that's totally okay, by the way, in the medical device world. It's fine to put something together that does a certain thing as long as you say what it does and tell the authorities what it does and don't promise that it will do anything else. There's a second issue of, is that actually safe? But we can solve that in other ways. So what I found happened in this project is people writing the specs would do pie in the sky. Oh, it's going to be amazing. It's going to do all these things. And then I would show them results from the lab saying, you're not even any close to that. So it's all fail. And they would go, oh, it's not failing. Let me just rewrite this. There, see, everything fits now. Once I had done this investigation, now I can reduce this to automated fact-finding and feel better about it. So I can write code in R in this case that automatically creates this display, which is a combination trigger heuristic and radiator heuristic, because it's not just telling you that anything in the red zone is a fail according to our standards, but it's also, you can look at the profile and get a sense of trends and information like that based on the starting power level. So this is a nice rich oracle. I love rich oracles. Oracles that are trigger oracles and radiator oracles and decider oracles all wrapped up into one is fascinating to me. It's beautiful to me as a tester. So I discovered a bunch of things while looking at this massive data by zooming way out and coloring it. All these things. All right. Now, let me pause and tell you a little bit about the dynamics of what are going on here. I urge you to read about Sensemaking in the writings of Carl Weick. Sensemaking in Organizations is a book that really changed how I think about testing, about organizational behavior, but about testing specifically and about scientific work. And Carl Weick lays out 7 elements of sensemaking. And what surprised me about this is how social they are. Of course, he's a social scientist. But it occurred to me that even when I think I'm doing highly, highly technical mathematical work, I'm actually doing all these things. Especially that first one, which really threw me for a loop the first time I saw it. Like, I'm doing this technical work. I'm trying to figure out, what should I name this variable, or should I use a closure here, or should I run my code style checker and it says I'm violating this standard? Well, is it really a standard that matters? But throughout all of that, there's always a thought that comes back to me, like, what if someone I respect sees this code? What will they think of me? So that's grounded in identity construction, where you say, what would a good person do in this situation? And I'm a good person, so I'm going to do that. Every time I'm testing, all throughout the process, I am constructing my identity, I'm expressing my identity, and for me, my identity is I'm a tester. So I think, what would a good tester do? I also write code, but I don't think of myself as an artisan of writing code. I think of myself as I'm capable of swinging a hammer and not making holes in walls. I can get stuff done in code, but I don't have any sense of pride. If someone says, that's ugly code, I go like, well, yeah, I guess so, whatever. I'm not really competing in the Olympics of coding style, so I don't really mind. But I am competing in the Olympics of test strategy. So if you say, your test strategy is 1% less optimal than it could be, then I'm going like, oh, I will stay up all night and fix it. It's grounded in identity construction. It's retrospective, enactive of sensible environments. This is a fascinating concept. What it says is that when you make sense of something, when you construct a model to make sense of data, you are also taking actions to change the environment to give you the things that you need. And to me, that's a fascinating thing, how the observer and the environment are all tied together. Now, of course, we can take all these things and we can apply them to testing. I would rewrite them for testing as saying that I'm applying my mindset as a tester to consider what happened as I design tools, tests, and conditions as a team throughout the project so I could spot clues, etc. Sense-making is a huge part of testing, and sense-making is a human, psychological, cognitive, and social situation. Now, how does that interact with what I'm calling the blink? Where I would locate blink testing is in this process. This is the blink testing process. The moment of blinking is just after you encounter data, especially data that is overwhelming to your senses. Magic can happen when you encounter data that is overwhelming to your senses. So you encounter data, you react to it. You don't know how you're going to react to it. That's why this can't be automated. As soon as you pick something and say, I could have written a such and such algorithm that would have found that, then I go, that's great. And if you already know the bug that you're looking for, you of course can do that. What if you don't know the bug that you're looking for? What if the bug you're looking for, what if the security vulnerability isn't yet in any security vulnerability database? And you just have to encounter it and wonder and pull a little thread in your mind and follow that thread to something that no one yet on your project has even thought of yet. That's where blink testing lives, that moment of human attempting to grapple with something that is complex, overwhelming, ambiguous. So the blink moment is between the moment of encountering and the idea of making sense of the data. I periodically defocus. So in the blink process, I encounter the data, and then I adjust and I adjust and I adjust as I pursue various theories, and I refine. But periodically, I worry I've over-refined, and I try to defocus and go back to the blurry big thing without coloring it again to see if something else occurs to me. So sense-making is tied up all in this. Now I will define a blink oracle. A blink oracle is an oracle wherein a tester encounters a radiator of overwhelming information and reacts to it. It's that reaction you have to data assaulting your senses. This is in contrast to a mechanical oracle, which we can code up. An algorithmic procedure where it doesn't matter who the human is, what kind of mindset the human has or anything, it's just an algorithmic procedure. Mechanical oracles are great. We use mechanical oracles all the time, but it doesn't encompass blink oracles. However, you can mix them, which is cool. You can have a mechanical oracle that facilitates a blink oracle, or you can have a blink oracle that makes use of mechanical oracles. They can cooperate. There's various forms of blinks. Zoom blinks are what I just showed you. Speed blinks, I'll show you one in a minute, where you make things go past your eyes super fast and you just catch something in a few milliseconds. Flip blinks are the most classic kind of blink, where you flip back and forth between two screens and look for differences. I did an audio blink one time and it made my ears bleed basically, so I've never attempted to do it. But if you take an AM radio and you put it within a few inches of a microprocessor and you tune it until you hear strange noises that seem like not white noise, you will notice that depending on what's happening with the processor, it makes a different tune. It makes different sounds. And so in a completely non-intrusive way, you can tell if threads have become stuck or hung or going crazy in any way. The problem is well, let me put it this way. I went to the espresso house for the last few days on Kungsgatan in Stockholm, and they kept playing the same record over and over again, like the same 8 songs in a loop for days. So I must have heard 7 hours, 8 hours of this music. That was music, and I couldn't stand it after that time. If it's just buzzing of different levels of buzzing, I can't do 8 hours of that, okay? So I heard somewhere years ago, somebody wrote a log file analyzer that plays like the sound of a babbling brook as it's analyzing things, that becomes this horrible buzzing whenever you're under some sort of attack. And I was looking for that software. I've not been able to find it, so it's out there somewhere. I would love to hear about someone who does something with like soothing ambient sounds that change, but boy, it's a big challenge to do an audio blink. Educate the intuition. This is a big part of doing a blink well. The more literate I am, the more I know about what the data means or could mean, then the more likely I am when I just glance at data to say, there's a problem there. There's something wrong with this data. Let me look closer, as opposed to flashing up the data and saying, that's okay, move on. And of course, I want to arrange things so that ugliness is bugliness, so that if I see something that isn't pretty, it's probably wrong. And then that's an interesting art to writing software that helps you do that. So let me show you some examples. Here's another from the medical device project. What you see here is a test of 10 medical thermocouples. And it starts at the top, where the medical thermocouples are in a cool water bath. And then they are switched in the middle there by a tester to a hot water bath. We have known temperature. And the middle there is that moment of transition. So I was given raw log files, and I was asked to graph them some way, do some statistical analysis, and could you automatically detect if it passes or fails? Thanks. So as I was scratching my head over this, I tried some different things with graphs, but then I came back to this idea. Oh, let me just zoom the data out and color it. And then you can just glance at it, and if you understand what you're looking at, in this case, what we're looking at is, this is the 4-second mark after the transition. And say I wrote software that automatically detects by looking at a characteristic hook in the data that, oh, this must be where they switched from the cool water to the warm water bath. The data kind of does this little hook that after studying a lot of log files, I noticed this little hook, which is kind of a blinky thing, by the way. I'm saying, how can I do this analysis? I guess I'll just look at the data and see if I can see any characteristic signal here. I came up with that signal. And then 4 seconds after that, the system, the thermocouples have to be within 4 degrees of the reference temperature. That's represented by the green line. So all I'm doing here is I'm just looking at the green. I should see green, 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 and then green has to start in there. And I just glance at that and say, this is fine. But I also look at this, and I go, what about these gray things? Notice this gray here. It all starts at this. These are supposed to be independent thermocouples, but this doesn't look like very independent behavior. What the gray is the longest stretch of unchanging temperature. I've decided to mark it as gray. Why did I do that? Was there some sort of requirement? No, I just thought, that's an interesting thing to focus on. Maybe something will come out of it. So when I did that, I noticed that sometimes the thermocouples, which are, by the way, tiny things that are on the same stick, I noticed that sometimes they exhibited correlated behavior. And they shouldn't be correlated. I mean, they should be somewhat correlated because they're all in the same place, but they shouldn't be exactly digitally correlated. There should be some sort of random variation on when they stabilize. Each one should be somewhat independent. So then I set off on that kind of analysis. How did that analysis begin? It began with noticing a strangely ordered pattern. So then let me go to the next one. So then I took that experience and looked at all that data, and I constructed a hybrid mechanical blink oracle. This is the mechanical part. This is a statistical analysis of all the data, and the statistical analysis marks things at red when they're red when they're out of range statistically. That's not a blink test because it's trivial, like red is bad. That's not really a blink because you're not making any sense of anything. You already have made sense of it. Red is bad. So I'm not going to find unanticipated problems here, unless maybe there's a pattern of red, like it makes a smiley face or something, and I go, well, that's odd. Why would the pattern of red make a picture of a Ferrari? I think someone's messing with me. So there could be some blinky thing about it. Another part that I did is I tried to brainstorm and imagine all of the kinds of bugs that I could automatically detect with the software, such as the temperature goes below 0. I know from the test setup that we're not dealing with ice, so it can't ever go below 0. So if it does, we already know that's wrong. So we see all these alerts in this data. This particular data set was constructed for me by the testers to test my software that was looking for these problems. That's why you see so many failures here. This is a whole bunch of unintentional failures constructed to try to trick my software. And then this is the blink. This is a whole set of tests, and I just click from one worksheet to the next, and it's full of failures. So purple means it didn't get data for a thermocouple at all. It was expecting data and didn't get it. You see there's lots of places where there's no green. It just means the temperature was never in range. I can just click quickly through, and if I see the nice green, then I move on. If I see anything weird, then I can stop. That's a blink. These, by the way, these guys who I did this for, they didn't ask for this. That's the interesting thing about testers that I often consult for, is they don't know what to ask for. They just say, like, make some magic code, coding tester, that will automatically make some kind of graph and that will be helpful. I recorded for 20 minutes them just talking to me about what they wanted, and then I listened to that several times. They didn't know what they wanted. What I had to do is use my skill as a tester and my interest in visual design and complexity and displays and statistics to try to come up with something that when they saw it, it would be like someone seeing an iPhone for the first time. They would say, I used to like Nokias and now I like Apple phones. Here's another simple example. I just saw this website the other day. Oh, I'm thinking that it really isn't 55 degrees there in Detroit, Michigan, surrounded by 15 degrees and then 55, just unlikely. So this is obviously a blink kind of situation. Here's a attempt to do stress testing of a mind map product, Xmind. And so I created a random mind map, but then I duplicated the same thing 4 times and connected everything with connectors. And then I'm glancing at it. I'm expecting symmetry. So anything that is not symmetry, I look closer at it. And here is a attempt to test the distribution feature in Inkscape. So what I thought is, you know, the object distribution feature, it spaces out objects. So what I did is I created 10,000 little diamonds, wrote code to do that, and boom, there it is. And then I thought, when I do the distribute, it won't change it. It'll just be the same because they're already distributed, evenly spaced. So this is what it actually showed me. Ah! This is so weird for me that I had to question, do I even understand what distribute means? It turns out I didn't know. I didn't understand the algorithm. I didn't understand what it was trying to do. I had confused distribution with something called unclumping. This is the unclumping feature of Inkscape. And you see it does do the thing that I expected, but barely moves anything around because it was minimizing, equalizing edge-to-edge distances. I had slipped into expecting that. What distribution does is it takes all the objects in either dimension, X or Y, and it says, where are these objects? Now, what is the space we have to work with? Now, we're going to divide that space into an equal set of spacings, and then we're going to take each object and move it to one of those positions. And when you think about that deeply, you realize this actually makes pretty good sense. But it doesn't seem very mathematically regular. I would have expected something very mathematically regular. This looks like a photomicrograph of some kind of virus. So I deployed a mechanical oracle. So in this case, the blink oracle was a trigger that told me I need to look more closely. And this is the mechanical oracle. So I deployed R, the R language. Oh, I hate it. Will you guys please stop making languages that are just single letters? Come on. R. I try to Google it. The worst is processing. You Google for processing, and it's like, process, that's just a word, dude. The next thing is they're going to have a computer language called the, or called Google, called hits. So anyway, what I did here is I extracted from the SVG file the X and Y positions of each of these dots, each of these objects, and then sorted that and looked at the difference between their sizes, and you see this is pretty good. This has a variance of 0.000009, extremely regular spacings. Even though it looks kind of organic or whatever, it actually is okay. But when I did this circular feature and did the distribute and saw this, it also looks irregular. I used my mechanical oracle and I find out, oh, this is actually wrong. This has gotten less distributed after activating the distribute feature than when it started. So this is an example of the limitations of a blink, because you can glance at something and say that looks about right, and it turns out that in some specific way, it's actually quite wrong. But if you just blink and that's all you're doing, then you're going to miss those things. So it is supposed to be a diamond. I know this because I constructed a correct algorithm, ran through the same data. This is what it's supposed to look like. So it is actually supposed to be a diamond, but it's supposed to be not a raggedy diamond. It's supposed to be an exact diamond. And my parallel algorithm says everything's fine. So I think what the bug is that the distribute algorithm in Inkscape does not work for all kinds of ways that objects are specified in space, which I didn't even know until I started this testing, that in Inkscape, things can be specified not just in X and Y coordinates, but with transformations and rotations and all kinds of complex things. And in some cases, that's going to defeat some of the features. Okay, here's a nice one for you. I was helping my brother out, who's at eBay, and he was in charge of search testing at eBay. So I thought, my brother, like a lot of great testers, doesn't code, so I come in and I introduce coding for him. So I say like, oh, I'm going to take a search for the word aeroplane, and I'm going to search for it 3,000 times as fast as I can. So every second and a half, I'm getting a new search, and then I'll just record the hits. And I thought that it would be a random walk, right? Like a drunkard's walk. Instead, I get this. What the heck's going on? You just look at that and you go, that cannot be right. What is it? What's happening? It's sometimes the hits are up here, and then it just drops down, and then 2 seconds later it's back up again, and then it's... Does anyone know what's happening off the top of your head? Anyone look at this and say, that's obvious. I know exactly what that is. Just raise your hand if you just think you probably know. Nobody? Well, yeah, what do you think? Just call it out. Caching. I thought it might be something like that. I thought it might be we're going to different data centers, and the data centers are not quite in sync. Maybe that's what it is. Turns out they use Hadoop. And so I didn't know anything about Hadoop. So I start reading about Hadoop. And like in Hadoop, you take your zillions of data points and you take a cup full of them and you pour them into this little server, and another cup full goes here. And so when you do a query, you're querying like 1,000 servers at one time, which seems counterintuitive to me, but that's apparently how they do it. And what's happening is, our theory is this way. We haven't got it confirmed by the people on the back end team. But our theory is that there's a handful of servers that are not getting back in the timeout period, but it's randomly distributed. Like sometimes they come out in time and then their hits get added to the total, and sometimes they don't. So yeah, caching was definitely one of the things that we investigated. But while I was investigating this, I sliced and diced the data in a whole bunch of different ways. I created a animated histogram, and I wrote all this code. This really was a project for me to learn R. That's why I was doing it. It was just an excuse to learn R because I thought I might need it someday. I did QQ plots. I did correlation charts. I just tried to chart this stuff in all kinds of different ways to try to glean some clues about what might be going on. This is data I scraped off of the page for hit numbers for subsections like collectibles and clothing and books, and sometimes there were interesting different patterns there. But then finally what I did is I wrote a simulator that simulated my theory. What if the servers are organized in clusters, and not only are individual servers sometimes not contributing their hit total to the total, but sometimes an entire cluster doesn't respond in time? You can get exactly this pattern. This bottom line is when an entire cluster doesn't come back, and these other ones are servers that are more or less flaky. So this looks pretty close to what I got, so this makes me feel comfortable that I'm on the right track. But notice where this started. Where this started is I'm expecting some kind of drunkard's walk. Instead, I get this thing that's weird, and I'm trying to make sense of it. I am trying to investigate it. I am trying to reslice and refocus the data in different ways so that I can get to the bottom of it. That, to me, is the essence of testing, not pass and fail. The essence of testing is the investigation, is the curiosity, is wanting to find mysteries and get to the bottom of those mysteries. And by the way, this is not very easy to do when somebody thinks the way testing should work is to take a JIRA card, and then you got 40 minutes to write your test cases, then move on to the next JIRA card. More test cases and less investigation, you tester. So I'm constantly hearing from testers who say, like, that's testing stuff you do sounds so interesting. I wish my company wanted me to do any of that. Instead, I'm doing very shallow fact gathering, and that's what we call testing in our company. And by the way, we don't have any testers anymore. My last example is a speed blink. Here's a speed blink. I was asked by a company to analyze a log file. There was a challenge for me. I'm teaching a testing class. They said, we have this log file. You were talking about doing stuff with log files. Here's a log file. Analyze it. So I don't know anything about it. All I know is it's a radiological imaging system. So here's my first idea. I'll just say type log file and just watch the screen. And that's what I saw. This So I'm just blinking on this. And I love this because every time I do this and show this to people, it's like that Beautiful Mind movie, right? I'm just going I'm just analyzing it, and like the stuff I'm seeing, a Rulezilla is coming to me right now, and it's some errors, and then this happened. And there's issues with the video, which is why you're seeing the blinking there. But this goes on for minutes and minutes. So I started to get the notion that there was something strange going on here. This gave me an idea. The idea is to write a cluster detector, which took like 5 minutes to write. So this is the cluster detector, which is just looking for error messages that are clustered together. And as we just quickly scroll through this, you'll find, 201,297 error messages in a row. But wait, it happens right after midnight. So that's another little pattern recognition moment. Again, remember, of course you can write something that automatically detects stuff like this, but first you have to conceive of the thing to write about. I came to this thing not knowing what I wanted to examine this for. I don't know. So I look at it with an open-ended mind. I notice something, and then I focus. You see me focusing right here, and then I notice that 200,000, and then 24 hours later, 229, 11 seconds later, 396. I'm thinking there's something with involving time zones, or with a process that starts before midnight and then ends after midnight, and then it's confusing the system because the date times don't line up. Something like that. We have a clue. We have a way to proceed now. Okay, this is the last bit in my 44 seconds left. You're going to miss something, James. Yep, that's true. That's true of any oracle. All oracles miss something. So I'm not saying that blink testing will find all things. I could have found that bug with such and such algorithm. Yes, if you already know what to look for. And of course, blink testing leads to mechanical oracles that can give you lots of fun and profit. But don't you need to be literate, hardworking, and lucky to make a blink oracle work? Yes. My suggestion is to be those things, and then your blink oracles will work. So it's not something where you can take some shuffling person who goes, I don't even want to test. Do a blink oracle tester. Oh, try, I guess. They're going to be horrible at blink testing. Well, to do blink testing, you got to be the kind of person who says like, it's just going to be a great day. I'm going to stare at stuff that I don't understand, and I might just find a thing that will make us win. Or maybe nothing. Maybe nothing will happen, and I'll just go home again and feed my cat. But then tomorrow, maybe I'll come and I'll see something super complicated that I don't understand, and we'll win. That's my attitude when I go into testing every time. But again, I love testing. Not like that white book that Kent Beck wrote. He doesn't love testing. He said so, but I love testing. So for me, that's the essence of it. Thank you very much.